In this video, we're going to be talking about how to graph inequalities on a number line. So there's just a couple of basics that you need to understand in order to match an inequality with what it looks like on a number line. So what we're going to start with first is the type of symbol. So in this table here, if you look at my two symbols, this one says less than, and this one says greater than. Notice they don't have the little bar underneath it. If it does not have that bar, then the kind of dot that you put on the number line is an open circle. Because what these two symbols mean, less than or greater than, means that the graph gets close to that number, but not equal to. So for example, if I had x is less than 3, that means on the number line at 3, I would have an open circle. Next, we're going to talk about which direction I would shade. But for now, at least I know it's an open circle because it does not have a little bar under it. It's not there. So then these, since they do have the bar under, that's a filled in circle because that means it includes that number or equal to that number. Here's the way I think of it. If I need the extra ink to draw that little line under the symbol, then I need the extra ink to fill in the circle. That's how I remember. Okay, so let's talk about which direction do you shade. So if I look at these symbols in this graph, that one says less than. This one says less than or equal to. So both of these are less than type symbols. One does not have the equal to, one does. When I graph less than, what if it's x is less than a number? So for example, x is less than 2. On the graph, I would shade to the left and to the left of that number. Again, my example was, let's say it was 2. So x is less than 2. When x is on the left side, the inequality symbol actually points in the direction you're supposed to shade. So this inequality symbol is pointing to the left, so I shade to the left. That also means all numbers smaller than c, whatever number you're using. Again, in our example, we were using 2 as our number. The only thing that's different if it's got the equal to bar underneath it is that it's going to be a filled in circle. So still points to the left or goes to the left. Filled in circle because it has the equal to, and it means all numbers including and smaller than c. And I'm using c as just any generic number, positive, negative, fraction, decimal, doesn't matter. Then here in this next row, I've got greater than, and I've got greater than or equal to. So again, when x is on the left-hand side, this symbol is pointing in the direction that you're supposed to go. So if it's greater than, since it doesn't have the bar underneath the symbol, it's an open circle, but it points to the right. And if I have greater than or equal to, it's filled in. So with this first number line, that means all numbers greater than c. Again, we're using c as just a generic number. And then the second one is all numbers including and greater than c. So what we're going to do in this example, this is similar to what you could see on your content assessment. So we have a number line and we're matching it with the inequality. So if I look, this is an open circle. So that means I'm looking for an inequality that's either less than or greater than, with no bar underneath it. So if I look at my options, that's going to eliminate B and C. That's what the open circle tells me. So just by looking at that, I can eliminate two possibilities. Now that I see that it's shaded to the right, I know that it's greater than. See how I just kind of drew an arrow? Or let me do it this way. It's going to the right. So if I look at that arrow here, what I just outlined in red, that's the greater than symbol. So I'm looking for the greater than symbol. So that's my answer. Then in this example, the circle is closed or filled in, so that means I'm looking for less than or equal to or greater than or equal to. So that eliminates A and B because they don't have that bar underneath the symbol. And I'm going to the left, so if I look at my arrow, that's a less than symbol. So I'm looking for the one that's got less than. So less than or equal to, bingo. That's my match. Okay, so if you understand open and close, what does that mean? And understand how it's connected, which direction it's going is connected to the inequality symbol, then you can probably match it up just fine. Now what if, though, you've got a question where you've got x not on the left side, but on the right side? They're going to try and trick you that way. So let me do an example where we might have that happen. So which number line represents the graph of the solution to the inequality 1 is greater than x minus 2? So what I need to do is I need to solve for x. I'm going to add 2 to both sides of the inequality and get 3 is greater than x. Now, when I was talking about the direction, which direction it goes, that really only matches the inequality when x is on the left side. So I'm going to rewrite 3 is greater than x, but with x on the left-hand side. Now here's what I need to be careful of. Which part is bigger? What does the inequality sign want to eat? It wants to eat the 3. So that means it needs to still want to eat the 3 when I switch it over. So now it's not the greater than symbol, it's the less than symbol. So there's two clues. The fact that it does not have a bar underneath it, that's empty, means that it has to be an open circle. So that cancels out option B and option D. So the difference between A and C is that A points to the right and C points to the left. So if I look at which one matches my inequality symbol, it's C. So when you solve an inequality and x is on the right-hand side, be very careful. Take your time, think very carefully, and turn it around. But when you do, the inequality symbol also has to turn. This and this are not the same thing. So see, what I did in this case is I just switched the place of x and 3 while keeping the symbol the same. I can't do that. If I switch x and 3, I also have to turn the symbol. Okay, also on your content assessment, you could see what are called compound inequalities. Compound inequalities, we call them and or compound inequalities. An and compound inequality could look like this, where x is sandwiched. See what I did there? And sandwich, where x is sandwiched in the middle between two numbers. When that happens, you're going to have a graph that's sandwiched. I can't spell. between two numbers. So if x is in the middle, two numbers, your graph is going to be in the middle between two numbers. Now also notice, since this symbol did not have the equal to, it's open. Since this symbol did have the equal to, this dot is closed. So that's another reason why that matches up with that graph. An OR compound inequality is separate. Two separate inequalities separated by the word OR. If you've got two separate inequalities, you're going to have two separate lines. And they're going to point in opposite directions. Notice this one. That points to the left. Points to the left. This one points to the right. Points to the right. Neither one have the bar underneath, so both are open circles. Okay, another way that I remember this is or. It's like in a boat. You know, like you've got paddles. I'm not a very good artist here, so I'm gonna, oh, that's not too bad. So if you're in a boat and you're paddling, you've got two oars. They're pointing in opposite directions. Okay? And sandwich or opposite. So let's look at this example. If 2x plus 1 is less than or equal to -3, or x plus 1 is greater than 5, which graph represents all possible values of x? I have two separate inequalities. That means I'm going to have two separate lines. That actually automatically gets rid of A and it gets rid of C. So here's what I need to do. To be careful, I want to make sure and solve these inequalities first. So let's look at the first one. If I want to solve 2x plus 1 is less than or equal to -3, I'm going to first subtract 1, then divide by 2. -4 divided by 2 is -2. So that's one of my inequalities. If I look at the other one, x plus 1 is greater than 5, I'm going to subtract 1 and get x is greater than 4. So -2 and 4 are my numbers. If I look, -2 and 4 are my numbers anyway. It's kind of like that was my only option for where I have my open and closed circles. But really, I'm just looking at B and C, B and D, I'm sorry, those two. So I need to see which ones match up with the inequality symbols. If I look at this one, that has the bar, so it should have the filled in circle. B has the filled in circle at -2, so that's my answer. Okay, so understanding your ors and your ands, it's going to help you figure out one piece, and then most likely you're just going to have to look at the symbols and decide, does it have the equal to or not, in order to match the next one. So let's do another example, because this one it's kind of throwing in a trick that we'll have to talk about as well. Okay, when I look at this one, to get my numbers, to get my endpoints, or I get the open and closed circle, I need to solve for x. Now when you have a compound inequality and you solve for x, what you do to the middle, so again, this is a sandwich, x is in the middle. So actually, before I solve it, I could eliminate two possibilities. And sandwich in the middle. So the one that has the bars in the middle are A and B. C and D are two separate inequalities that go in opposite directions, so I can count those out. But to decide between A and B, what I need to do is solve for x. So what I'm going to do is I'm going to divide by -2. And if I divide it from the middle, I have to divide it from the left side and the right side. Now also pay attention to the type of number I'm dividing by. That number is negative. So do you remember when you divide by a negative, you have to turn the inequality symbol? Tricky, tricky. So when I look at the left side, negative 6 divided by negative 2 is positive 3. Then I'm going to turn the symbol. It was less than. Now I turn it to greater than. The negative 2's cancel, so x is in the middle. And then on the right side, 8 divided by negative 2 is negative 4. It said less than or equal to, but when I divide by a negative, I've got to turn it. So now it says greater than or equal to. So the two numbers that I'm looking for are positive 3 and negative 4. Pay very, very close attention to my number lines. This is negative 4, so that's checked, and this is positive 3. Check. So far that matches. To really confirm it, look at the inequality symbol that's attached to negative 4. It has the bar, so that means filled in circle. If I look at the symbol attached with 3, there's no bar. That means open circle. So this A matches. B does not match because my numbers were negative 3. It needed to be negative 4. Negative 3 is not the same. So you see how they were kind of trying to trick you? There is a question on the content assessment that might try and trick you like that. So pay very, very close attention. Remember, when you divide by negative or multiply by a negative, either way, you have to turn that inequality symbol. Okay, there's one more thing I want to talk to you guys about. This actually deals with the fourth objective, but I'm seeing a lot of students struggle with questions on the fourth objective that use this concept. So you guys are probably pretty comfortable with using the words less than or equal to, greater than or equal to. But there are some other words that we can use to describe these inequalities. Now less than and greater than, or more than or greater than, that's easy. But there are other words that we can use when we have the equal to bar. This is less than or equal to. So for example, if I want something to be less than or equal to 3, that means all numbers smaller than 3, or it could also be 3. So 1 is less than or equal to 3, 0 is less than or equal to 3, 3 is less than or equal to 3. Those all work. So there's tons of numbers. But another phrase that I could use is this one, at most. So if I said at most 3, think about these numbers. Is 1 at most 3? It is. 0 works. And 3, at most 3, means that we can include 3. When I have greater than or equal to, this also means I can use a different phrase. And this is at least. So in my example here, let's say I want to be greater than or equal to 5. So greater than or equal to 5, these work. 6 is greater than or equal to 5. 10 is greater than or equal to 5. 21 is greater than or equal to 5. There's lots of numbers that are greater than or equal to 5. You could also say 6, 10, and 21 are at least 5. At least also means, though, that I could include 5. So I could say 5 is greater than or equal to 5. Now, equals is not an inequality, but it is still a symbol. And we could also use the words exactly or is. So just to remind you that if I use the word exactly, that means it has to be all the way equal, not an inequality symbol. So let's practice with this. x is greater than 15. That means numbers more than 15. If I look at the next one, x is less than or equal to 21. Less than or equal means all numbers have to be smaller than 21. So the phrase that could go with this is numbers at most 21. 21 is the biggest possible number that could work. C, x is less than 1. So numbers less than 1. And then the last one, greater than or equal to -2. That means numbers at least -2. Meaning the numbers have to be bigger than, but could also be -2. So greater than or equal to, you could see is attached to the phrase at least. Less than or equal to, like we had in B, is attached to at most. So hopefully this video helped you with a couple of things that then hopefully you can pass your content assessment with. Good luck and thanks for watching this video.